right, so we're going to start it the same way we started the other ones. Okay, this one's going to be tough. I'm going to write a little bit smaller on this one. Okay, this problem is tough. This is hard. This is the hardest problem in the homework. It begins. All right, solution. so we start. SOL, yeah. So we start. Yeah, no, yeah. Well, so you start by writing the infinite sum. I used to have this teacher who used to do that. He would write SOL, but he was really hard. So, yeah, I didn't like that class. So we start at 0, and then we have C sub n. A nice guy though. He would always write SOL. All right, now we got to take a derivative, not once, but twice, right? So every time we take a derivative, we shift up also, right? So let's do it. So y prime, this problem is pretty tough. My night class was blown away by this problem. They were like, oh my God, what's going on?
John texted me and he was like, dude.
John? Oh, Michael Jordan?
No, John Shepard.
Oh, Shepard.
He was like, life is over.
So this is, yeah, we spent like an hour on it. So this is going to be interesting. See how long we spend in this class. It's not that bad. People were confused about what you were asking about earlier. The C0 and C1, that was the confusion, I think. That those are the arbitrary constants. So we're going to use that in this problem. So in this example, we're going to use what's called the indirect approach. Now we start at 2. Then we have C sub n. I'm running out of room here. N minus 1, x to the n minus 2. I don't know if you can see that. N minus 2, is that? Yeah, it's on the thing. Yeah, I don't know why I did that. It's weak. It's just, okay. Yeah, whatever works. Okay, so we're here. Now we got to plug it into the DE. So plug into DE. So y double prime, I'm going to come way over here. So we have infinite sum. I know I'm writing small, sorry. N equals 2 to infinity, right? C sub n, n minus 1, x to the n minus 2. So I've just plugged in y double prime. That's all that's been written on the board, right? Just the y double prime. Minus 2, x. Then we have y prime. So infinite sum, 1 to infinity, c sub n, x to the n minus 1. Okay. And then we go to the last one, which is 8y, right? So it's 8 times this one. I just remembered something that I never talk about that I could just talk about while I'm writing if I don't mess up and while you're writing. There's no retakes in this class, right? But the final exam does replace your lowest score, right? So you can get an A in the class. Even if you have a C in the class, you can still get an A. So if you...
Stay hard, kids.
Yeah. Yeah, your first test was a take-home, which was really good because of the hurricane. But like, it's also kind of bad because the final is a lot from the first test. So just make sure to study for the final. It's not bad, though. You can get 100.
So, dude, you could take all the questions from the first test, try and do it without looking at the answers, take a review, try and do it without the answers, go to the homework.
Oh, you'd be more than ready. Yeah, if you just do the review questions, you are ready. There's like 32 of them or something. If you just do those, that's it. You're ready. You'll get 100. Done. Okay. Before we do the thing with the k's, this is something that Rachel mentioned earlier. You see how there's an x here? We're going to distribute the x, okay? And when we do that, there's an x to the 1 here. So when you multiply these, you're going to add the exponents. So 1 plus n minus 1 is just n. So let's go ahead and do that first. I know it's painful, but we have to rewrite everything just to do that one step. It's like, so let's do it. Honestly.
Why are you doing that first?
Because if we call it k and we make it n minus 1, if we make it k, when we multiply by x, we'll get k plus 1 and it ruins everything. Yeah, good question. Yeah, distribute this.
Can we distribute the n on the first term?
I wouldn't. I would leave it like this. Good question. Good question, Ian. Let's just leave it. Yeah. You can, but it's not a good idea typically. It's not necessary. It doesn't help or hurt. It maybe hurts more. Yeah, it does hurt a little bit actually. Minus, I'm going to go ahead and distribute the 2 as well. So n is 1 to infinity. 2 c sub n, and then here's the key step. X to the n. Right, n. Because 1 plus n minus 1 is n. Right, that's the key step.
Why did you put the 2 in there
Should we put the 2 in there as well?
Why'd I put the 2 in?
No, the 2, but why are we distributing x again?
Because we want to have everything together before we make the thing with the k's. Because there's an x here, you want to put it in the sum.
Would 2 get swallowed by the cn?
You sure? You see how we did that?
Yeah.
If you don't do that and you just go to the next step with the k's, you have to distribute it later anyways. So then you would get k plus 1. Sorry, someone says I wasn't paying attention.
No, that's all right. Does 2 get swallowed by the C?
No, it doesn't. Just leave it. Good question. And then here we have 8 c sub n swallowed. I got a mental image when you said that of like a giant fish or something.
So
Like,
you pretty much you only want operators between the sums.
right. I don't know why I'm thinking of a giant. Oh, I know why I'm thinking of a giant fish. Okay.
Yeah, he has that.
No, the ship found wheel killed it.
Any questions so far on this one? We're okay with the steps? Any questions? All right. So now we do the thing with the k's, right? Now we do that thing with the k's. So we call this k. We call this k, which is psychotic. We call this k, which is even more crazy. So k equals n minus 2. I'm going to write even smaller now. Game over. No, I can't write smaller than this. I'll have to go to that board after this, I think. Maybe. So k is n minus 2. And when you solve for n, you get k plus 2. I'm going to have to go a little bit faster soon. Well, we have 20 minutes, 21 minutes. We're good. Slow time down. Then here we have k equals n. And n equals k. Whoa, magic. K equals n. N equals k. I just made this up. I don't even know if this is in the book. I didn't learn this on my own. Yeah.
What will the second term be? K equals n minus.
Yeah, because the exponent.
Oh, yeah. I see.
That's what makes this one a little bit harder. Yeah, it makes it more annoying.
Rewrite the whole thing.
So yeah, rewrite the whole thing. I got to rewrite the whole thing. I don't know if I should write it here. Can you all see down here? Is that okay? All right, I'm going to do it here then, okay? So I'm going to start over here. So we have infinite sum, and then we'll go to that board. We've made a lot of progress on this board, so that's really good. So k here starts at 0. Yeah, because 2 minus 2 is 0, right? So to infinity. And then it's just a lot of bookkeeping here. So n is k plus 2. So it's c sub k plus 2. N is k plus 2, so k plus 2. K plus 2 minus 1 is k plus 1. And then we have x to the k. Right? Minus. And then these remain unchanged, right? N is k and k is n. So nothing really happens in these, right? You just keep the k's in the n. Can you see? Sorry, you keep these. Everything is the same in this case, right? So all I'm going to do now is I'm going to rewrite all of this and just keep it the same.
Are you going to change the n for k stuff?
That's all I'm going to do. Yeah. So let's do that. So k is 1 to infinity 2 ck k. I know that's really bad. When I write the ck, it's you have to be careful.
What I do to help me see it is I do a parentheses around that k.
You could do that. Sure, go for it. Yeah, because I know, right, Patrick? You do this and you're in a hurry. It's like, ooh, ck squared, game over, right? Yeah, right. It's really easy to mess up. Yeah, plus, weak. K equals 0. Let's squat down. Infinity, 8 ck. I wish I was shorter. X to the k. No, I'm kidding. I don't wish I was shorter. Equals 0. It's not. No one says, I wish I was a little bit shorter. I'm like, no, that's so I can squeeze in under things. No. Huh? Yeah, there's, never mind. Okay, any questions up to here on this one? I was gonna say there's a teacher once I've heard of, some art at school, and she's really short. And when she teaches, she can only write this high. It's like if you come into the classroom, it's
Just move the board to the board.
that's kind of, she's a really good teacher, yeah.
You have a k equals 1. Is that what we're doing?
I know, it's kind of uncomfortable. Yep, I know.
So now we combine the first one and the third one.
Not yet. Not yet. We could do that, but we want them all to start at the same thing, at the same number. So do you remember which one we have to make a start at?
Plug in the 1. Right?
Yes. No, plug in the zeros. The highest one. Good, Jarrell. So we want them all to start at the highest one. We want them all to start at 1. That's always the rule, okay? So you just take a 0 and you put it here, take a 0 and you put it here, and you start them all at 1. If this was a 3, then they all have to start at what number? 3. So you plug in 0, 1, 2, plug in 1, 2, and you start them all at 3. Okay. What if this is a 3 and this is a 6? What do they all start at? 6. And here you plug in what? 1,
2, 3, 4, 5.
and then here
3, 3, 4, 5.
Right. That's for the take-home. The take-home has one that's brutal. At the end of class, if we have time, I'll help you with that. There's a key step on number 7, which is completely insane. But I don't know if we'll have time. I don't even know if we'll finish this problem. Let's just keep going. So now I'm going to rewrite everything. Start at 1 and plug in 0 here and plug in 0. So I'm going to come to this board here. So rewriting this. So I have infinite sum. K equals 1 to infinity. We're starting them both, all of them at 1. So C sub k plus 2. K plus 2. K plus 1. X to the k. Right, starting it at 1. Right, starting this one at 1. And then minus, this one's already started at 1, so I'll leave it. So minus k equals 1 to infinity. K equals 1 to infinity. 2ckk, I have to really focus. It's a lot to copy. 2ckk x to the k. My handwriting is terrible. Let me just, there we go. It's a little bit better. And then k equals 1, 8ck. Got it. So plus infinite sum. K equals 1 to infinity. 8ck x to the k. And then we're not done, right? We're not. Yeah, we got to add those terms. So let's see, let's be really careful. So here we have to plug in 0, right? So it'll be C2 times 2, right? So 2C2, everyone see it? Because we're plugging in 0. So goes away. So 2C2. So it's plus also, it's a plus 2C2. It's really hard. Plus 2C2, and then, then here. 8C0, like a pro. Oh, you're born for series, Matthew. So, people have a hard time with this. This is pretty sophisticated. This is like the last topic in DE. So, yeah, I don't have videos on the internet for problems this long because I always give up. I've tried to make them with that thing I write on, the black one, and I remember a couple of years ago, this girl was like, "Oh, can you make a video?" I was like, "Okay." So I went home, I tried it. I tried it like 3 times, and I gave up every time. It's too long. I only can do it because you're here to help me. Like, you catch my mistakes, right? Like, oh, you should be at infinity there. Oh, like, Huh? This is a review question.
I mean, you could do when making.
So then you're expecting it from
and do the problem like here at school, make the video, and then pause after every so often to check your work.
Oh, that's a good idea. Oh, yeah.
Put it together and then bam, and you have your source.
That's true. It's true. It's a good idea. It's a good idea. This one will be on the internet eventually if it's recording. So minus 2ck plus 8ck. And then here we have x to the k plus all of this. Right, ridiculousness. We probably won't finish this problem. I don't know. Let me not be so negative.
Go faster.
We still have 15 minutes. Maybe be positive. Let's be positive. It's kind of cool if you think about it. Like, people were doing this like 100 years ago. Same problem, right?
Not a board.
Huh?
Not a board. Just paper and pencil.
Well, I think they had boards 100 years ago, didn't they? Or
They had whiteboard? Well, they had the
chalkboards. Yeah, they had chalkboards. I like chalkboards, but yeah, I like getting it on my face and my. I don't know. Okay, let me just. All right. So now we set each piece equal to 0. I don't know why I said that. So we take this and set it equal to 0. So we have C sub k plus 2. It feels like you work. Like when you get chalk all over your hands and your clothes. It's like if you work outside, you know how you get dirt on your hands and like.
Oh yeah, I know what you're talking about.
Yeah. I used to do tree work, and I've done all kinds of work. So.
Did you climb the trees?
No, my buddy was a climber though. I would just like jump on the truck and tear it down with the chainsaw. Really brutal. This starts at 1. It starts at 1. So, yeah, it was fun when I would take my friends with me to work with him, for a day. To see how this, like, hey, you want to come work, make $50? They totally destroyed.
Did that with my friend. We used to work at a horse ranch.
Horse ranch?
I brought him in for one day, he never came back.
Yeah, I've done that. It's so much fun. Makes you feel good about your job. Like, yeah, I can handle this. Then you have to set this equal to 0 as well. This is a constant term, okay? So the entire term gets set equal to 0. This is extremely important. So you don't set each piece equal to 0. You set the entire term equal to 0. So 2c2 plus 8c0 equal to 0. So the entire piece is equal to 0, okay? I hate to derail, but let me just emphasize this some more, because this is very important. Let's suppose for a moment just really briefly, and I shouldn't do this, but it's too late because I've already started, so I can't go back. Let's suppose for a moment that you had like 2C2 plus 8C0 plus, I don't know, C3x plus 4C4x equals 0. If you had something like this, you would group these like this. Then you would factor out an x here, right? You would write it like this. This is for the take home. This example might be nonsensical, but who cares? And then we have an x here. And the point I'm trying to make, I guess, is that you set each of these pieces equal to 0 individually, right? So you set this equal to 0, and so you would do 2C2 plus 8C0 equal to 0. Then you would do C3, I can't write any faster, my arm hurts. Set that equal to 0. So that's the point. This is not going to come up on the homework, but it'll come up on the take home.
I'm just thinking, what if the DE wasn't equal to 0? And you can't.
Oh, it will. Oh, yeah, it's different.
So in my head, I'm like, well, I have to group all together. That equal to that term.
Why don't you move 2C2 plus 8C0 over to the other side and then divide it by, or to isolate CK plus 2?
No, because we're equating coefficients. So basically, all of this is equal to 0, and all of this is equal to 0. Because this is equal to this. That's the constant term. Good question. So again, if you have multiple terms, like over here, if you have like x terms and stuff, group the x terms together, then set them equal. This is for number 7 in the take home. Again, work together on that one, right? Just, you know. Because it's really tough. Like, it'll take you hours for that. I mean, it's very hard. All right, so now we're here. So let's finish. Let's at least get this far. Which one do we solve for? K plus 2, the one with the k or the k plus 2? The k plus 2, the bigger one, right? The one with the bigger subscript, right? Why? Because it works. So I'm going to do it in steps. So c sub k plus 2, k plus 2, k plus 1. And then we add this and subtract this. Yes?
I think I might have made a mistake, but I want to understand why. When you're equating the coefficients, that line, I have a negative 2C2.
Oh, it's from here. It's positive.
Oh, whenever you plug in 0 for the term all the way at the top of the board.
This one? Uh-huh.
Over 1.
You don't plug in 0 for this one. It's already at 1. Yeah. So then add this. So you get 2. I'm going to put the k in the front because it's really bothering me. 2k. I'm going to improve my handwriting. ck. Now we won't be able to finish. It's all right though. Minus 8ck. And now we're going to divide by k plus 2 and k plus 1. Okay, so we have c sub k plus 2 equals. I'm going to
Set them both equal to 0. You set them equal to each other.
No. You set this equal to 0, right? And then you set this equal to 0.
Okay.
So we're solving this one for c sub k plus 2.
Oh, okay.
So we added this over and subtracted. No, it's okay. No, that's all right. Ask. I'm going to make a really bold move here, but it's okay. It's good for you. I'm going to pull out the 2 and the ck and then divide by this. So it'll be 2k minus 4 c sub k. I'm letting it hang out at the end for notational purposes. That's the top. And then on the bottom we have k plus 2. This problem is notorious. K plus 1. And this is for k equals 1, 2, etc. Okay, etc. So we're here. Okay, I'm going to put this in a box because that was an accomplishment. That's the recurrence relation.
What do you do with the other one?
Very good question, Matthew. So just like before, we continue our pattern. We solve for the one with the bigger subscript. So we solve for C2. Super important. So solve for the one with the bigger subscript. So subtract C0. 8C0. 8C0. Divide by 2. So we get C2 equals negative 4C0. I'm going to put that in a box as well because that is extremely important for us to use in this problem. Right? So we're here. If you had this example here, this fake example here, in this case you would solve for C2. And in this case, which one would you solve for? C4, because it's the one with the bigger subscript, right? Very good. So that was a really good question that Matthew had, like which one to solve for, right? The one with the bigger subscript, okay. So now we're going to take the indirect approach. We have like 8 minutes, we probably won't finish it, but let me explain it. Let me explain how it works, and then next time we'll do it. So the indirect approach is a made up name. I made that name up, okay? It's just completely made up. So here's the idea. So You could just plug stuff in and look for a pattern, but yuck, right? What if you can't find the pattern? In fact, this problem is so tough, we won't be able to find the pattern. Something else will happen, and it's really tricky. So here's the idea. The final answer, we know that the final answer is C0, Y1 plus C1, Y2. We talked about that before. Let me write a little bit cleaner. So the final answer is C sub 0, Y1 plus C sub 1, Y2. That's the final answer, right? And then we find the little C0 and the C1 using these, right? And in the previous problem, it was, I believe it was cosine, and it was sine in the previous problem, right? Okay. So in this problem, finding the pattern is just too hard. So we're going to manipulate this to find the answer. Here's how you do it. So let's pretend we wanted to find y1. So to find y1, I've never written this down before, ever on the board. Try something new. Maybe this will make it make more sense. I've never written it. Hopefully it makes sense. So to find y1, let's think about what we can do to find y1. So we would need to get rid of y2. And so if we got rid of this, what would c0 have to be for y to be equal to y1? 1. So we set c0 equal to 1 and c1 equal to 0. If we do that, then y is equal to 1 times y1 plus 0 times y2. So y is equal to y1. Yes?
Why can we assume y equals y not y1 plus c1 y2?
That's always the case. So remember, we know that the final answer is big C1 y1 plus big C2 y2.
That's the answer, we know that.
Yeah, from previous chapter 4. And in the previous example, if we can use that as a guide to convince ourselves, we saw that it was actually this. Remember? Oh, still on the board! Look! Oh, you see it? See, that's the y1, that's the y2. So the idea is, yeah, that's it. That's yeah. So that's y. So do you see why though it's equal to y1? When we do that, everyone see why? So you want to memorize this. So this gives you y1. Okay, so on the take home, it says y1 fill in the blank. This is what you do. So you plug in these numbers and then you just plug in numbers. You know how in the previous example, Matthew said, what happens to the C0 and the C1? They just hang out? They won't hang out anymore. They'll be gone, right? They'll be just numbers. So it makes it easier to find the pattern because you have pure numbers. To find y2,
So you just plug in 1 and 0.
yes.
Just plug them in.
You just plug them in.
They come from just their like placeholder to.
Yep. Yep, to find the format. Yep. And to find y2, it's very similar. So let's see, we would have to make c0 equal to 0. And then what would c1 have to be to find y2?
C1 would be 1.
Would be 1. That means you get it. Oh my God, so good. Yeah, my night class had a really hard time with this. Probably because I didn't write this down. I didn't write down to find y1.
Oh, yeah.
Yeah, that's kind of important. Yeah, I just said it. I kept saying it, but I never wrote it down. Maybe that's why. I don't know. Oh well, it's too late. Hopefully they do good on their test.
Write it down right away.
They'll watch it. No, this video will probably not be up for a while, but yeah, if they ever watch it, I'm sure they'll be fine.
Now, did you say you had any videos doing this test?
Yes. Yes, not this one. This one I don't have, but I have the one you missed and the one we did before this. I have videos of those on the playlist.
Is it this is called the indirect?
No, they're both the direct.
Indirect approach.
I don't have any of the indirect ones because I'm weak.
So how does y equal y1 help you solve the problem?
Okay, very good. So once we do this, right? Once we have y1 and y2, then, so after we do all of this, then and finish. That's the idea. Right? Because we have y1 and y2, we have two linearly independent solutions. We know the general solution is a linear combination of those solutions. So once we have like cosine and sine, we know the final answer is this. Right? So once we have these, we do this. And then to find the c's, we go back way over here, right? Way over here, and we use our initial conditions, right, to find the c's. So that's the plan, right? We're not going to be able to do it today, but that's the idea. You know what we should do? We should just start it. So you see how it works, then we'll start it again next time. So let's, you know what? This didn't happen. So first let's do this one. So first y1. I'll even write it down. I never do that. Let's be different. So c0 equals 1, c1 equals 0. Oh, it's too far away, but it's okay. So we have this.
Read something to you over there?
No, I'm going to walk over there, because check it out. Now we have to find C2. Well, where do we look to find C2? We look here. So if C2 is negative 4C0, that's going to give us C2. So C2 is negative 4 times 1. So C2 is negative 4. I box them all. Why? Because I don't want to lose track. It gets so complete. We're not even like close to being. We're all maybe like another 30 minutes.
We're gonna pick up from here next time, right?
Yeah, we're going to pick up from here next time. So we're here. So now what do? So you do this, because you memorize it. You use this condition to find C2. On the take-home test, you'll have, oh, it's gone, but you'll have multiple things like this you have to use first, okay? So we use this, we take the 1, we plug it in here. That gives us the C2. So now we have to find C3. But check this out. If you look over here, when k is equal to 1, you get C3, right? So when k is 1, you get C3. So now what you do is you do this. You do, okay, k equals 1, C3. Well, C3 is over here. So it'll be negative 2. Oh my God, yes, even better. What's C1? 0. So all of this is going to be 0 because it doesn't matter, right? So C3 is 0. Everyone see that? Because we plug in 1 here, C1 is 0. See? C1 is 0. So it's 0. And then you do k equals 2. K equals 2. So k equals 2 will give you C4. So you get C4. So then you go over here and you plug in 2's for everything, right? I'll go ahead and do it. So you get negative 2. So we're going to get negative 2. It's k minus 4, so it's 2 minus 4. C2 over, I'm going to do all this over next time from the beginning. I'll rewrite everything on the board and start over. So this will be negative 2 times negative 2. Oh my God, it's too hard. So negative 2 times negative 2. And C2 is negative 4. 4, 3. Completely ridiculous. I don't even know what's going on. What do you do here? Let's see. Math.
Well, I mean, you got, is that a negative 2 outside? So
This shouldn't be a negative 2, should it? Negative 16?
Yeah, let me just do the, yeah, so it's going to be negative 16. Yeah, negative 16 over 4 times 3. So 4 goes into 16 4 times.
Why is that negative 2?
The negative 2 is already there. It's hanging, it's not a negative 2? Oh my God, it's a 2! It's a mistake! Oh, so well, yes, you do, but class is over. No! No, I should have stopped class. All right, so it's still right. Is that right? 4/3? It is, right? Is it right? Is it right? Gibson says right. It's right. All right. Next time, I'm going to write this down right at the beginning of class, and we'll start over to continued. And do you all have those notes? Do you have the? So what was the C sub k plus 1, or was it C sub k plus 2? Can you read it to me? What was it?
2k.
No. What is it though? C what? C.
C k plus 2 equals 2k c sub k minus 8 c sub k all over k plus 2 times k plus 1.
K plus 2. K plus 1. And then we had some other condition, didn't we? Some other, like, the little dangling parts. Do you remember what the other condition was? It was
C sub 2 is equal to negative 4 c sub 0.
Okay, very good. And then we had initial conditions at the beginning of the problem. Do you remember what those were?
Y of 0 is 6, y prime of 0 is 0.
Perfect, thank you so much. So this is what we had from last, yes?
Is that C sub k or 8 C sub k or the 8 C k?
It's 8 C sub k. It's 8 C sub k. Yeah, it's 8 C sub k. Good. And these are C sub k's. Yeah. And so as you write down, the first thing I'm going to do is rewrite this because this can be written in a better way. Right. What we can do here is we can pull out a CK, and we can also pull out a number. We can pull out a 2, I believe. Right. So let's do that. So C sub k plus 2. This problem is really tough. Is equal to 2 CK parentheses k minus 4, and then on the bottom we have k plus 2. K plus 1, right, k plus 1. And then we have this condition up here. I'm going to put this in a box because this is important. And I don't remember what this was, but this was valid for k equals, anyone remember where it started? Was it 1?
We started it.
Anyone know? Was it 1?
Yeah.
Was 1? Was 1? So 1, 2, etc. Okay. This is where we continued from last time, right? So just continuation of last time's super problem, right? So, and I think this is like number 9 in the homework or something, right? So this is just like a regular homework question. I think, Josh, you finished it, right? How long did it take you to finish it, Josh?
Small problem. Worked on it for about an hour.
About an hour.
2 days.
Good. It's good. It's good. It's good. I was hoping you'd say like 24 hours, but no. Like 3 days. No. All right. So now we're ready to go. So so we're using the indirect method, right? We were talking about that, right? So the way it worked, I'm going to write it, then I'll erase it. So the idea was, so I'll go over it one more time. The idea was that the final answer was C0y1 plus C1y1. That's the y2. That's the final answer, right, to the DE. And the idea is that when we do this, we do the following. We make C0 equal to 1 and C1 equal to 0. And when that happens, what happens is that this one goes away. So you just get y equals y1, right? Because this is 1 and this is 0, right? So that's the first thing we do. And then we flip them, okay? So we do this, C0 equals 0, C1 equals 1, okay? And in this case, that gives us y equals y2, okay? Once we have these, we can write our final answer down, and then we can use our initial conditions, and we can finish the DE. So this is the indirect method. So your take-home test is actually due next time, right? Your test is next time. I posted an announcement on WebAssign, how many questions. Your in-class test is really easy, right? Just go over, I gave you review questions this time, because you have the take-homes, and I felt bad. So just go over the review questions, and you'll be okay. But you need this for number 7 in the take-home, right? So because it wants y1 and y2 in that problem. Okay. So first we're going to do this, okay? That's what we're going to do first. Okay, so let's do it. So C0 equals 1. Not a lot of people here today. It's because it's the day before Thanksgiving. The faculty parking lot was like empty. And then C1 equals 0. So we have this. So we have these two conditions here. Okay, these two here.
C2 is -4.
That's what pros do. Yes, very good, because you go over here. Good, yes, oh my God. Yes, because now you use this to get C2. Yes, oh, from the air. So C2 is -4. Very good. So C2, it's -4 times 1, right? Times, I'll put the 1 there, but it's really -4. So it's going to be, I forgot the negative. There it is, right there. See, that's pros do that. They don't forget stuff, but I did. So C2 is -4. C2 is -4. So we have to do that first. So we use this to find C2. On the take-home, it'll be like that also, right? Except it's worse because you have a bunch of stuff like this, right? Okay, so now we have to find, remind me at the end of class to give you a hint for the take-home question. Please remind me. Don't forget, okay? It's super important. You're gonna write it down? Write it down.
Right in the corner or something.
Write it down. Yeah, hint. So don't forget. Here, don't
That helps.
forget. The hint. It's really important. Without this, you'll get super stuck. I'll know what I'm talking about because I'll remember it. Okay. Yeah, it has to do with this. Okay. Okay. So now we go to this. So when k is equal to 1, we take the 1 and we plug it in here. So we'll get 1 plus 2. So we get C3. So we get C3. Hi, Matthew. So we get C3. So we get C3. So k is 1. Oh, yes. Yes, this is so good. Look what happens here. When you plug in 1, you get C1. But what is C1 in this case? 0. Very good. 0. So this whole thing is just 0. Yep. Isn't that cool? Because C1 is 0, right? So when you plug in 1, you get C1 here. So we got lucky. I'm going to put this in a box. I like boxing stuff. It just keeps things organized, right? Keeps things organized. And again, when you're working on your take-home test, don't feel discouraged if you can't do it. It's normal. Remember, you get partial credit too. And plus, the majority of your test is take-home, right? So in class, it's not that many points. So anyways, k equals 2. When do we stop? I have no idea. Let's just keep going and see if we can find a pattern. So k equals 2. That'll give us C4. Explosion. C4. C4 is an explosive in movies. So we get C2, so 2C2, this one's going to be not fun. This is going to be 2C2, 2C2, and then 2 minus 4 is -2, so that gives us -2. And then 2 plus 2, 2 plus 1. So 2 plus 2 is 4, right? And then 2 plus 1 gives us 3. Ian's not here today.
I remember that.
Yeah, a lot of people skip today. It's normal. It's just the way it is. C2 is 4. Oh, it's negative 4. It's really confusing. So it's 2, negative 4, negative 2. Why am I not multiplying stuff? I have no idea. Yeah, now we can do it all now. Or we can cancel. We can cancel
Yeah, it's negative 4.
the negative, the 4s.
Yeah, 4 there.
So this is going to be
4 over 3.
4 over 3. Thanks. 4 over 3. I'm trying to...
I guess it's good to show it, that way in our notes we can see where it's coming from.
Yeah, but yeah, I don't like skipping steps when you do this. It's really easy to mess up, right? That's why they take so long to do in class. It's because we're actually going really slow. When you do these, you'll probably go a lot faster, right? It's just there's so many little steps. Like, yeah, Patrick's right. So C4 is 4/3. So C4 is 4/3. This DE is famous, by the way. It has a name. Wasn't it the Hermitian differential equation or something? Yeah, it's some famous differential equation, the one we're solving. So we're solving something famous. Kind of, yeah. I don't know who that was, but
Why is it famous?
I don't know. I Googled it, but I didn't read that much about it. But he told me about it, and it's true.
This is about where we ended last time.
Okay. Okay, let's keep going. Let's do for k equals 3. Hey! So for k equals 3. So for k equals 3, we get C5, right? C5. Oh, this is beautiful. Because when k is 3, we get C5, right? But C3 is 0, right? C3 is 0. So this is just going to be 0. So this is just 0. So it's 0. So it's 0. Because C3 is 0, right? C3 is equal to 0. So when you plug in 3, you do get 0. So it works out really nice. Let's keep going. Again, I don't know when to stop. I don't remember what happens in this problem. I wish I did, because I would feel better about it. I'm just gonna come over here just to use this piece of the board because it's there. So k equals 4. Notice how I underline everything and box everything? That's for my benefit too, so I don't get lost, so I know what's going on, right? It's good to be organized. So k equals 4 is gonna give us C6. Oh, what is this gonna be? Anyone know?
C4, which is 4/3.
C4, which is 4/3. What's the whole thing going to become, though? When you plug in 4, what do you get?
0.
0. Yeah, everyone see it? Because 4 minus 4 is 0. This is beautiful. Zeros are good, so this is 0. I'm going to put that in a box. Again, just box everything in. Keep it nice and neat. Yeah, I forget you're in Calc 3 tonight, right? Yep.
When we do that, though, we always got to be careful and make sure that the bottom's not undefined.
Yeah, oh, if that happens, there's like some serious issues. Like, you did it seriously wrong, probably. So, yeah. Oh, there's something really bad going on if it's undefined. Yeah. No, you should. No, it's good. It's good. Yeah. All right, let's see. K equals 5. Let's see what happens there. So k equals 5. It's going to give us C7, right? Because 5 plus 2 is 7. We get C5, though, and I think C5 is 0. So this is 0.
So it's 0, so it's like forever 0.
It's forever 0 now, because when you plug in 6, you get C6. But C6 is 0, right? So now when you have they're all going to be 0 now. If I plug in 6, you plug in C6 and you'll get 0. So I'll just do it just for clarity. When you plug in 6, you get C8, right? But C6 is 0, so the whole thing is 0. So let's do what pros do. So now we can just say C9 equals C10 equals ... 3 dots equals 0. So they're all 0 from this point on. We rarely get to do that in math, especially like, I don't know, it's pretty rare. When you put equals, it's like an infinite set. It's like infinitely many equalities there, right? So there's infinitely many, and then it's all equal to 0. It's kind of fun. I know, it's pretty cool. I know. It's like, you can't do that every day, right? I mean, I guess you could. You could wake up in the morning and write that down on a piece of paper, but I don't know. Any questions?
So we're doing this for
Y1.
Y1.
So now we're going to write down Y1.
So, well, you call this the indirect approach.
Yeah, indirect approach. So now we're gonna write down Y1. So Y1 is equal to, well, it's C0 plus C1x.
Because we basically just made this up.
So, and then I'll do one more. Right, so now just go back to the original function, which is y, but it's y1. Remember, oh, I erased it, but via our trick, it's going to be y1 via our magic trick. So it's equal to y1. So this is interesting. So you just write that down, and then on the take-home test, it'll tell you how many terms. It'll say like first 4 non, so you know when to stop. Okay? Yes.
What is y1?
So the final answer is this. The final answer to the DE is this. So yeah, I did that right. Yeah. So y1 is your first solution. The general solution is the linear combination of the two solutions.
So that's the first one, and then you did it again. I'm guessing it was for C2 minus 4CO, that part. But when you did that, it was YC1, or y equals C1, Y1 plus C2, Y2. That one's different.
Oh, was that last time? Yeah, last time I wrote it like this, maybe?
Yeah, is that the same?
Same thing. Yeah, I'm just using different C's. I'm using big C's. Because generally, Matthew, when you see it in other sections, it's like this.
Okay.
Right? Remember on your second test, we would write it like this. I was just trying to relate the fact that these arbitrary constants are actually your little C's. So that's all.
Okay.
That's all. That's all. So you can just think of it like this if you want.
But when you did it, your C0 was equal to 1.
Right.
C1 was equal to 0.
That's right. That's right.
And then you reversed it for Y2.
I'm sorry?
And then you reversed it.
Yes, correct. Right, because to find y1, if you do this, you would get 1 times y1 plus 0 times y2. Very good. So you would get this.
Okay, I see it. You're going to plug that into your
Yes, let's reverse it just to make the point, because you asked and it's worth it, because this is the part that, there it is, okay. This is the part that's really confusing for people. My night class was super confused about this. I mean, I think they were. Maybe a few people were, I don't know. But they did really good on the test. So I think everyone in my night class got an A on the test. Maybe there was one B or a C, maybe. But that was due because they didn't do the take home. Like they just, yeah.
No pressure.
Yeah, yeah. They didn't work together. With you just make friends. So, okay, so now we can plug everything in. So we know all of these things, right? Now we know all of these numbers. So we know little c0, we said that was equal to 1. Right, so that's 1. So 1 down, 1. So 1, it's progress. C1 is 0. Yeah, C1 is 0. Right, C1 is equal to 0. So that one's gone. C2 is here. C2 is here. C2 is negative 4. So it's going to be minus 4x squared. So minus 4x squared. C3 is 0. C4 is this weird fraction. Not weird, but it's just a fraction, so it's 4/3. So C3 is 0. C1, the odd ones are 0. C4 is 4/3. So this is 4/3. X to the 4th.
So this is going to be cosine?
No, I think that's it. Because C5 is 0, and everything else, so it's just a polynomial, actually.
Oh.
Yeah, I know, right? Yeah, it's weird, isn't it? Yeah. Yeah, I think, is it a Hermitian polynomial? Is that the right? Okay.
Everything else goes to 0 unless you slumped over, so it forces the polynomial.
That's good. I'm going to read more about it later. When you said that, I'm like, really? I looked it up on the internet, mathworld.com. It's a great website. And it had it there. The DE we're working on was there. I'm like, oh my God, we're doing a cool problem. Like, it's something from, I didn't know. I didn't know. It's kind of interesting. Yeah, pretty cool. Okay, so that's y1. Any questions on how to find y1? Any questions on how to find y1? So everyone see how we did it? So you first do this, and that always gives you y1. You just go through the steps. All right, now we got to find y2. So I'm gonna erase this, okay, and I'll do it over here. So we can actually fit it all in here. So I'm gonna do this, separate our train of thought. So now let's find. Let me write it again. C sub k plus 2. I'm just gonna write it again, so we have it over here. 2ck, k minus 4. Just copy pasting, k plus 2, k plus 1. So k plus 2, k plus 1. And then we have the dangling parts. We have this. And this is for k equals 1, 2. So I'll finish it over here, just so you see it. So now we're going to find the other one. Now we're going to find y2. I just wrote it over here so I could reference it, because I don't want to mess up. Okay?
Why are you doing this again?
Because now we have to switch them, like you said, right? I know, it's a long process, right? This is why there's a take-home portion, right, for the tests. I usually don't give take-home tests ever. It's just, this is kind of like, yeah. Okay, so C0, I have to suck it up and do it. C0 equals 0, C1 equals 1. C0 equals 0, C1 equals 1. We're flipping them now. This is going to give us y, 2. Yeah, the second one. Good. Y2. So now we can use this dangling part here to find C2, right? So it looks like it's going to be -4 times 0. So -4 times 0. So it's just going to be 0. So C2.
So finding the Y2 is always going to be easier than finding the first one?
No, this is going to be actually way harder, actually. This is where people would get stuck. This is where people get stuck. This is ridiculously hard. You'll see.
I thought we already had all the stuff related to each other.
We do. We do, but this you'll see what something's going to happen. Something evil will happen.
Oh, boy.
Oh yeah. This question was actually on an in-class test, I think, last semester, and a bunch of people gave up. So you'll see why. All right. So when k is 1, it's funny when it doesn't happen to you. So when k equals 1, they did it fine. K equals 1. So then you get C3. Right. 1 plus 2 is 3. So C3. C3. Yeah, again, usually, even if people miss a question, usually everyone gets an A or a B on this test. It's like, no matter what, it's just no matter what. You know, it's almost over. People try really hard. So K is 1, so we get C1, so now we get, that's a CK. That's a really ugly CK, I'm sorry. That's a C. Doesn't look like a parentheses.
Yeah.
You thought it was? I'm sorry. Here we go. There we go. Okay. Ugh. Okay. And that's a parentheses, and that's a parentheses. Okay. So it'll be, at first you thought it was, though. Yeah, I don't blame you. I thought it was, too. So this is 2 times 1, right? Because C1 is 1, right? I skipped a step there.
Okay.
C1 is 1.
Yeah.
Okay. I got confused. So 1 minus 4 is -3. 1 plus 2 is 3. From plus 1 is 2. Oh my God!
Is it going to be 1, -1?
-1. Yeah, I'm gonna box that. That feels like an accomplishment. So it's -1. That's -1. And again, when do you stop? I don't know, right? You stop when you feel like you should stop. That's the problem with this one. Things are going to get out of hand. Let's keep going. So when k is equal to 2, k is equal to 2. What do we have? Let's see. We have, we have C4, right? Because 2 plus 2 is 4. And we're plugging in C2. But fortunately, C2 is 0. So the whole thing is 0. So this is 0. So this is equal to 0. So that was good. So C4 is equal to 0 in this case. All right, now we got to do it again, right? So when k is equal to 3, let's see. So k equals 3. So when k is equal to 3, we get 3 plus 2. So we get 5, right? So we get C5. C5. And let's see here.
-2 on the outside there, right?
So this 2 here, and then what's C3? -1. Oh, that's how you get the negative. Okay, so -1. Plug, hey! And then 3 minus 4 is -1. This is ridiculous, right? Yeah. So C3 was -1. 3 minus 4 is -1. We're plugging in 3, so we get 3 plus 2 is 5 times 4. Right? So 20. So 2 over 20, so 1/10? Like, what the heck? Right? That's not even a factorial or anything, right? Like, it's not, what is that? Right? I don't know. It's just a number, right? 1/10. 1/10. Your glasses are an interesting color. Like, that's cool. I know what that's about. So, right. So k equals 4. So are these sunglasses also and regular glasses? That's really cool. That's really cool. It's a cool color. So k is 4. That's going to give us C6. 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 So, so what's C6 going to be?
0.
0. Why?
Because you got to plug in 4 for the CK and C4 is 0.
Beautiful, like a pro. So C4 is 0. Yep, very good. So when do we stop? I don't know. Let's just go a little further. Right, in this example here, we stopped because they were all 0. So we said, okay, we have a pattern, right? We know it's just going to be what we have. But here, we don't know. We don't know yet. So let's keep going. So when k is equal to 5, we get C7, right? C7. So C7, so k is 5. Oh, wow. Wow, this is going to be fun. So it's 2 times C5, which is 1/10, right? And then times 1, because 5 minus 4 is 1. Crazy, right? We're plugging in 5. right? So it's going to be 7 times 6, right? So it's 1/5 over 42, right? So C7, so it's really 1/5 times 1 over 42. When you divide by 42, you multiply by the reciprocal. So 5 times 42 is 210. So at this point, like, it feels really bad, right? Because we're getting like, we started off with -1, right? Now we have 1/10. It's like, okay, it's not even a factorial. Then you get 1 over 210. You're like, what's going on, right? So at this point, we should just move on. And say, what do you mean? Well, I don't know what the pattern is, okay? I'm sure there is one, but I don't know what it is. We could probably find it if we thought about it. But you could just go on forever, and you probably wouldn't find the pattern. That's why people get stuck on this problem. They go up to C15 like, the time's up. Yeah, right? See, here you know when to stop, right? Because you have, but here, what's the pattern? Who knows? So what do? We go to the next step in the problem, right? Why? Because there is hope. We have these initial conditions, right? So there is some hope. So maybe we can find the pattern later. So let's keep going. So now let's just go back to what we have. So we have y equals y2. Y2 is C0 plus C1x. So if you didn't do this, if you didn't know to do this, you probably wouldn't be able to do the problem, right? You would just keep going forever, probably, right? Unless like you found the pattern somehow. But it's a really funky pattern. I don't know what it is. I have some ideas on what the pattern might be, but I'd have to sit down, like, and work it out. Probably Google something, just to check something. You'll notice the signs aren't even alternating. Wait till you see when we plug it in. It's not plus minus plus. It's like plus plus minus.
Yeah, I thought it was third.
Yeah, it's really weird.
Some random time it becomes 0.
Yeah, and then it randomly becomes 0, right? What is that about, right? It's like plus plus minus 0. Whoa, crazy. So C0 is 0. So that one's 0. That's the random 0. So that's 0. I won't write that one. And then C1 is 1. So it's going to be x. So it starts with x. Makes me think it's a sine function, right? Because it starts with x. C2 is 0. Okay. C3 is -1. So so it makes you feel like it might be a sine function, right? Because it's x cubed, or something with a sine function, maybe, right? C4 is 0. All the even ones are 0, I think.
All the evens are 0, so it's just the odds.
So it's just the odds. So 1/5. No, 1/10. 1/10 x to the 5th, right? Because C5 is 1/10. C6 is 0. C7 is 1 over 210. So this will be, it's also plus. How strange and awkward, right? So see, it's like plus, minus, plus. It's plus, minus, plus, plus. I wonder if the next one is minus. It probably is, right? There's some weird patterns out there in math that aren't just plus or minus. There's other ways to alternate the signs. So that's y2. So that's y2. That's y2. So on your take-home test, just to emphasize that again, because it's due on Monday, if it says the first 4 non-zero terms, that's 1, 2, 3, 4. Boom, you're done. That's all you got to do, right, on that really hard one. You don't have to find the pattern on that one because it's too hard, right? So don't worry about it, right? If you find it, that's awesome. No one's ever written it down before. Hey, Jarrell, all right. Okay, so now we have y1 and now we have y2. So now we're going to put it together and finish. So. Any questions? Any questions on this one so far? And by the way, for those of you walking late, I do have a video on the internet that has this entire problem already worked out. So just see me, I'll tell you where it is. I posted it this morning. Yeah, I added it this morning at 8 a.m. It's my night class. I posted the whole lecture. It's like 2 hours and 20 minutes. It's insane. But we worked out the entire problem. So it took a long time. Yeah, it took us 2 days, right? So yeah. Fun times. Any questions so far on this one? We're not done. Now we got to finish, right? We're going to use our initial conditions and find the actual answer.
Can you do that at any point?
Yeah. So I just kept going, and I was like, oh, we got a pattern, so good. Here I'm like, let's just we could have kept going, right? Most people, what makes this problem so hard in the homework is that you can just keep going forever and you don't know when to stop. right?
When you know to stop and you plug it back in and you're going to solve for your initial conditions, what is that called, if you will? Is there a name for that?
Oh, like what we're doing
We're
next?
doing the indirect approach, or we're doing the indirect. Then there is a direct approach. Now,
Yeah.
this seems to me to be kind of,
Yeah, yeah, it's a little bit. So the indirect approach, basically you find these two,
yeah.
and now you go back to the final answer. Now you go to the final answer. So it's like this. So now you do this. You do y equals, I'm going to use big C's now, okay? So big C1, these are the big C's Matthew asked about. So y equals big C1 y1 plus big C2 y2. I'll leave this up here. I don't want to lose this. We need that. Okay. Okay. So now you just plug in your y1 and y2 into this, right? So y equals big C1, right? Big C1. And your y1 is over here, right? So it's 1 minus 4x squared plus 4/3. So you hear 1 minus 4x squared. The first time I ever did this problem, I also was like, oh my God, what's going on? When I saw the 1 over 210, I thought, no, I don't know what that is. And I decided, like, it took me a minute. I'm like, I got really confused, and I kept moving on. So if you don't know to move on, again, it's. And then C2 is that infinite sum way over there. This one, right? This thing here, and we don't know what this is, right? We don't know. So x minus x cubed. That. So I'm going to write that over here. So it'll be x minus x cubed plus 1 over 10 x to the 5th. 1 over 10 x to the 5th plus another plus, right? Ridiculous. Plus 1 over 210 x to the 7th plus dot dot dot. So it's this infinite sum. And now we're going to find the C's. You might say, well, we don't know the pattern. Well, we don't need it, right? We can differentiate infinite sums, right? We can do that. We just differentiate term by term, right? So now we're going to use our conditions. So remember, before this was the little c0, right? Before, this is what Matthew asked about, right? Before, this was the little c0, and this was the little c1, right? This was the little c1 before, okay? And so we made this one 1, and this one 0, and this one 0. Now we're just calling them big C's. So now let's take the derivative. Right, just take the derivative. So this is a constant times a function. So the constant hangs out. The derivative of 1 is 0. This will be negative 8x, right? Negative 8x. This will be 16/3 x cubed. So 16/3 x cubed. Okay, did I do that right? I think so, yeah. 16/3 x cubed. Yeah, not a lot of people here. It's a pretty small class, only like 20 people in this class. Okay, make sure you work together, or like, if you don't have any friends in class, like after class, like just hook up with some people or something. Because remember, it's due Monday, the take home. You want to have some friends that you can check your answers with. You know, it's important. The problems are real. The last one's really tough. Like, you don't want to like ruin your Thanksgiving. You know. You won't ruin it. Yeah, hey, it's just a math problem, right? Even if you left it blank, you can still get an A or a B, or yeah.
But don't do that.
Don't do that. And you get partial credit. This is 1. This is 1. This will be minus 3x squared. 5/10 x to the 4th. It's 1/2. Yeah, good. Thanks, Gage. 1/2. I was thinking about turkey. 7 over 210. 130. What time is it? No. So 130. Sounds like a time, right? X to the 6th. Dot, dot, dot. Those 3 dots.
What did you do there exactly?
Took the derivative.
You derived all of them?
So derivative.
Okay, I see now. I just did a little derivative sign. I'm back.
Yeah, no, yes, there it is. I'll wait. Look at some water. Some water. It's a nice problem. This problem is worth doing. Whoops. Any questions so far? Now we're just going to use the conditions and we're done. We got this. Oh, that's good water. It's from the earth. Okay, so, oh, wow. So I was thirsty. Y of 0, really good water. So plugging it in here, right? You ever drink water and be like, oh, it's good water? Like, yeah. It's just from the sink at my house, right? But like, I don't even think it's filtered. Well, it is. It is. 1 minus 0. Oh, these are all zeros, right?
Why are they all zeros?
Because we're plugging in 0.
Oh.
No, ask. No, this is, yeah. Plus C2 times, what's all of this going to be because of all the zeros? 0. Zero.
But isn't it 1 minus all that stuff?
No, this one is 1 minus 0. Now I'm doing this one.
Hey, okay.
You see it? So 1 minus 0. And then all of this is 0. All of this is this 0 here.
Okay.
Doing the top one. We're plugging in 0 to the top one. So 1 minus 0 is 0.
Okay.
And then all of these are 0.
Oh, okay.
We're doing this.
Where it says
You're gonna
y
say
of
equals
0
6.
equals 6.
Oh yeah, we have to do 6.
Now I'm following. No.
Yeah, I forgot about the 6. You equal to 6. You see it?
I was picking that up at the same time as you were saying it.
No, it's good, it's good. No, ask, it's your life. And then this is C1, right? So C1 equals 6, right? Because all of this is 0. So I'm gonna put that in a box. That's like huge. We finally found C1. It's like, you get it? Yeah, it's good. Are you taking PDEs next semester, the partials, maybe? No. Not yet, oh, okay. But eventually you have to, right? Maybe, or you're going to, or you don't have to? I don't know, yeah. All right, so let's keep going. Let's find the other one. So y prime of 0. So I have to plug in 0 to this one and set everything equal to 0. So it'll be C1 times 0. So all of this is 0. C1 times 0. It's cool that you're learning this too. Like I never learned this in school, ever. Like I never took a class where I learned this. It's kind of sad. Okay, and then so this is 0. And this is C2. 1 minus 0. Right? All of this is 0. Right? All of this is 0. And then that's all equal to
0, right?
0. Yeah, because it's from this.
So C2 equals 0.
So C2 equals 0. So we don't even care about what this is because
All that crap.
it's for nothing.
Do it all.
Yes. Right? Because C2 is 0, so we don't even need the pattern because it's all going to go away. So now that we have C2 equals 0, because see, this is C2 equals 0. So now the final answer, all of it, just plug them back in here. This is gone. All of this is going to be 0 because C2 is 0. So we're just left with C1, which is 6. So 6. So 6, parentheses, 1 minus 4x squared plus 4/3 x to the 4th. The last thing maybe to do is distribute the 6, right? It'd be really bad, like, because we mess up, like 6 times 2 is 4. So this is 6 minus 24x squared. 8, because 3, yep, 8. And that's it. That's it.